Hey everybody, welcome. This video is going to be about beginning a little course here on coordinate geometry. Now, it's important to remember what we've learned so far. We know things about parallel lines. We know things about perpendicular lines. We know how to find the midpoint of a line segment in the coordinate plane. We know how to find distances, or the lengths of lines, or line segments, I should say. And we're bringing all those tools with us, and if you need to refresh those, obviously the videos are still there. And so this video here is going to be pretty much a technical description of the parallelogram. And I think what you'll probably have to do here is just take some notes, and in the next video we'll actually do a proof dealing with parallelograms. Okay, so let's get started. And what I've prepared for you here is, okay, 8.5 is going to be all about parallelograms and things like that, coordinate geometry. I'm kind of just sticking it all in one big section. And so that's why I put the 0.85.1. I don't know if you can see that, because there's going to be 0.2, 0.3, 0.4, and as we get through all this stuff. So basically what I think we'll have is going to be kind of like you'll have a video describing the properties and maybe a video of a proof or whatever it is that we need to do to solve a problem. Okay. All right, so let's get started with this one. The parallelogram, I think everybody really knows what they are, but when you start doing geometry, suddenly it's kind of different than algebra. It's like everything has to be proved. And just saying something looks like one is not nearly enough. So we do have to get a little technical here and start to define things formally. So a polygon is any two-dimensional shaped form with straight lines. And so in other words, a circle is not a polygon, right? It's a two-dimensional shape, but it's not formed with straight lines. So triangles, quadrilaterals, pentagons, and hexagons are all examples of polygons. So specifically, I highlighted quadrilateral here because that means four sides. So polygons with four sides are quadrilaterals, and that's what we're going to be working with here. The name tells how many sides. For example, a triangle has 3. We all know that. A quadrilateral has 4. So the very beginning here, that's the definition of a parallelogram. A parallelogram is a quadrilateral. However, both pairs of opposite sides are parallel. Okay, so what do they mean by opposite sides? All right, for example, this side could be named AB. Right, you see it right down here. That's its name. It's got to be parallel to DC because they are opposite sides. In other words, AD is opposite BC, and they must also be parallel. All right, so what's got to be true? Parallel, 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 parallel. And then we are dealing with a parallelogram, which I guess is rightfully named, right? Okay. Now, for you guys that are in a formal geometry course, like in Math 2 and 3 and stuff, I know you would probably want to see more rigor than this, but for us in Math 1, when we're going to do some coordinate geometry, I said, well, for our purposes, there's 3 important properties of parallelograms to know, because a lot of our stuff comes in the form of coordinate geometry. And I said, well, first of all, opposite sides are congruent. Okay, that's talking about the length of these sides. The length of AB has got to be the same as the length of, I said AB, but they wrote it right here as AB and DC. They have to be the same length. If they're not, you can see these two lines wouldn't be parallel. It's pretty much, I don't want to say common sense, but it kind of is in that case. If one angle is right, then all angles are right. Now, I left that in there because that's going to come in handy when we're talking about a specific type of parallelogram, which is a rectangle. So we'll keep that definition right there because I think it's going to be nice. Here's another one. The diagonals of a parallelogram bisect each other. I probably should have drawn them in. So in other words, a diagonal means AC, and I guess we go this direction, BD. Those are diagonals. All right. That's sort of an intro video, just talking about this language, and you should write down these properties, draw your parallelogram, take some notes here. You're going to need them. And we'll get started on a problem next. And here's kind of how they look. Notice the word prove is used. And that's what we're going to work on next. And when they say prove something, that doesn't mean we can just say, oh, it looks like one, and I graphed it. And that's a typical response of people who haven't really run into these things. So we'll get into this in the next video, and I'll see you guys in a little bit.